Welcome back to another exciting chemistry lesson. In this video, we are going to learn about the law of definite proportion. And basically, according to this law, a compound or a particular chemical formula, a pure substance, will always contain the same mass percentage of element. And we are going to look at an example problem mathematically to see how that works. But what does that tell you? Well, let's say you have a sample, right? We can experimentally determine the mass percentage of each element in that sample. And then from there, we can determine if the sample is pure. Now, what does that tell you? Well, if you determine a mass percentage experimentally, and it has different mass percentage, well, that different in mass percentage comparing to the pure substance tell you that that sample right there contains impurities. So therefore, the sample is considered impure. Now let's look at a sample problem. Calculate the mass percentage of each element in a pure, notice how I use a pure sample right there, of 10 grams of this particular compound, C2H4O2, okay? And the way it works like this, well, first of all, don't get tricked by this 10 gram. It doesn't matter how big the sample it is. The mass percentage will always the same, and that's the beauty behind the law of definite proportion. It doesn't matter you have 100 grams, 1 grams. The mass percentage will always the same. So the way to solve this is that we are going to first need to calculate the total mass. So first of all, we are going to write this out. C2H4O2. And then we are going to find the mole mass, which is the mass of all the elements. So here I have my periodic table, the screenshot right there, right? So we can use this and solve it out. We need to find the total. Again, percentage is about total. So we have what? 2 carbon times 12.01. And we are going to use parentheses, okay? And then we're going to add 4 times hydrogen. 1.008, and there you go. And lastly, we have oxygen, which in this case is 2 times 16.00, and there you go. Now we can use decimal calculator and solve it for the total mass. But before I add in the whole entire thing, I'm gonna multiply, okay? So let's bring out a decimal calculator and plug it in, but I'm gonna do this right here. So in this case, 2 times 12.01, that is 24.02. And right here, 4 times 1.008, that is 4.032. And then 2 times 16, that is 32.00. And then 2 times 16, that is 32.00. Now you add them all up, right? And that will give us our total of mass. That turned out to be 60.05. There you go. So to find the mass percentage, remember this is your total, okay? Your total mass. Notice how we ignore the 10 grams. And all we have to do is divide everything by the total to get the mass percentage of each element. Now when we do our math right here, what we have here is 24.02 divided by 60.05. What do we get? So just to illustrate using a decimal calculator, okay, we have 24.02 divided by 60.05. Then we have 0.4. So there you go. Our answer is 0.4, okay? Now let's go to the other one. 4.032 divided by 6.005. So what do we have? In this case, notice how this is a decimal, but we can convert that to percentage easily. The next one we have is 0.067. Of course, you use your calculator to plug it in. And I just record down 3 decimal places, okay? And then down here we have 32 divided by 60.05. We have 0.532. So I round again to 3 decimal places. Now, to convert this to percents is really easy. All you have to do is multiply everything by 100%, or just 100, or move decimal place over here by 2 times because of that 2 0 right there. So 1, 2, and then of course we have, what is this? This is 40.0 0%. And here we move 2 decimal places. Again, this is the 20. And then what we have here is 6.7%. And over here, again, 2 decimal place, 1, 2. So there you go. So we have 53.2. And that is how you calculate percent composition of any compound from any given amount of any sample. Don't get tricked by the mass of the sample. Okay, again, the mass percentage based on the law of definite proportion, it stays the same. It doesn't matter how much of the sample you get. And as always, if the mass percent that determined experimentally is different than the mass percent that we calculate, that is a good evidence that so the sample has some impurities in it. Now let's go and check our answer. Again, carbon is 40%, hydrogen is 6.7%, and then lastly we have this right here, 53.2%. And then we are going to check. And there you go. Let's try another example problem. Here we have a sample of 52.1 grams of an unknown compound, right? And using specific equipment, we can determine the mass of carbon, the mass of hydrogen, and the mass of oxygen in that unknown sample, and determine the mass percent or percent composition of the sample. So again, percent is part over whole. So in this case, we have what? We have 52.1, okay? So for now, what we do, this is going to be our total, and this is going to be our part. So now let's go to carbon. We have 20.8 grams over 52.1. And we would do the same thing for each one of them. So we have 3.5 over 52.1. Notice how the whole doesn't change, right? And then we have 27.8 divided by 52.1. Now we just use a calculator. Notice I don't care about the percentage. I can do that easily in my head, okay? Now let's do the basic division so that way we don't make a mistake. It's turned out to be 0.40. And this I plug in the calculator, turned out to be 0.067. And for the last one, we have 0.533. Now, to convert to percent, that's pretty easy. You can multiply by 100, 100, 100. Well, because 100, all we have to do is move the decimal over 2 places. So this becomes 40%. And then this becomes 2 places. This becomes 6.7%. And then this becomes 53.3%. Now let's go and check our answer. 40% here, okay? We have 6.7 here, then we have 53.3 here. So now let's submit. And there you go. So notice how this is the same percent as the one we just went over last time. So that means this is the same chemical formula or the same compound. So again, using percent composition, we can determine the identity of that particular chemical or compound by looking at if it's pure or not pure, okay? And as always, if you have any question, show your work, take a picture, put it in the forum, and then we will help you from there. We will see you next time on another video.